Everyone. So today we'll be learning about what is Waterfall Model and a bit about introduction to the what is Software Development Lifecycle. That's SDLC to be precise. Let's get ahead. So SDLC or Software Lifecycle Model is a descriptive and a diagrammatic representation of what the software cycle actually looks like, right? And it represents all the activities that are required to make a software product and transits throughout its life. That is till the end, or it's not where when it's not been used and is decapiated to. And here comes the waterfall model. So, what is waterfall model? It is actually one of the first process models that has been introduced, and the name is derived from waterfall as it moves in a linear sequential life cycle, meaning once it moves to the next phases, it cannot go back to the previous phase no matter what, and that's a lot of work and that is needed to be done to actually go back and do such. And depending on how it's being made, it is classified into actually two different types. First is the classical and the second being iterative. So we'll discuss about what phases actually goes through. The first phase being, let's mark it as a A. So first phase being the requirement and the specification phase. The aim of this phase is actually to understand the exact requirement that is of the customer and to document them properly, so that the customer is also satisfied and the software developers is able to actually contribute or work around, get into the thinking of the customers and its function, what all functions they require, and interfacing requirements and such. It also, in other ways, we can say describes what a system is, right? What requirement it is needed to actually make the software, what it will do, the functionalities and such things are actually being discussed in this phase. The second phase that comes into the play is the designing phase. As we can understand from the phase wording, this phase aims to actually transform the requirements to into something that is in a suitable, or where we can say more suitable form, which permits further coding of the software, right? And all this work is documented as the, what we said, SDD, that's software design document. So what happens in this is, whatever work we are doing, that is from the that we got from the requirement specifications by the customer and the coding part that we have done, we make it into SRS form. In SRS, we write what are our functional requirements, what are the non-functional requirements, what all things our software is going to dependent upon, how it's working. Basically, it's a complete workflow. If there is a database, then what kind of database it's being used, what features does we provide, and much more. The third phase that comes into the play is the implementation and the unit test, right? So during this phase, once the design is implemented and the SRS or STD is complete, the implementation or the coding phase moves to the second round, because all the information that were needed we already have in a form of SRS or SDD, right? So during the testing part, we examine the code multiple times thoroughly, and it's being continuously modified. After few models, as we say, are tested, the new versions are launched by writing some changes or implementing the new changes. We move on to the fourth part. That's the integration and the system testing. It's a very important part, because if there is any defect in the software at a primary level, we can actually check it whether how it's working or not. And it's as I said, it's very crucial, as after that it's going to be released. So it's kind of what we should. The end product is determined at the stage, so the better output will definitely gonna lead to the better satisfied customer, right? So here we do the unit testing, which determines the actual efficiency of individual models that has been coded into the previous the round number, the phase number 3. And if this phase, if once all the modules are tested and their interactions with each other in the system has been verified that they work seamlessly, they work smoothly, we go to our final task or final phase. That's the operation and the maintenance phase. Okay. Okay. So here maintenance is a task that basically each and every user performs once the software has been delivered to the customer. They have installed and it's operational. If there is any changes to be made or there is some bug reporting, that all are considered in this maintenance phase. So in short, basically all these five phases are the core of SDLC. No matter what model we are using, these five will always be there. The only difference will be how what comes in between them, or which form they are represented in, whether it's in a waterfall method as we discussed, whether it's agile method or such form. So let's move ahead and actually see how does the classic traditional waterfall model looks like. Right. So here we can see that the every phase is in a form of linearly moving towards. What I mean to say is, like, once the feasibility study is done, it moves to the requirement analysis. After that, it moves to the coding, then the testing, then the maintenance. Here, the wording might be different. The requirement analysis is step one. Here, the step one is actually different. Let me clarify myself. Sorry, my mistake. The step one is the feasibility study. Now, how it's different, like the norm from the normal? Basically, feasibility study. Okay, so here the first step is a bit different. The rest is the same as normal SDLC cycle. Here the first step is, or the first phase that we can say, is the feasibility study, right? So the aim of this feasibility study is to actually determine whether what kind of product we are developing, or whether developing the product is financially worthwhile, whether it's technically feasible, it's operationally feasible, logically feasible, and when should be. Such things are being discussed in the feasible study. Other than that, it actually has a lot of work behind this part. That's why in the earlier days it was the first part. You can see it like it's the first process model that was ever introduced while making the SDLC site. That's why it has a bit more, what should I say, the steps in between, like between the feasibility study and the requirement analysis. The feasibility study, if we say, yeah, the feasibility studies then first moves on to the technical feasibility, right? And it actually checks whether potential risk, there are potential risk or not, or there is what should I say, there is any accumulation of such risk, whether it's so the first thing that in this phase is the feasibility study, right? So in the feasibility study, as I mentioned, like we determine whether the developing the product is financially worthwhile, technically feasible, operational, legal, or the scheduling part. So on that basis, it's divided further into the technical feasibility, that is TF, technically feasibility. Its main focus is to actually assess whether there are potential risks, and if there are, what are its solutions, right? The second part that I said was economically feasible, that is financially worthwhile. So let it represent by EF. So in this, we basically check the cost, the life cycle cost benefit. The third part that comes in is, write it here, operational feasibility. Here, we basically assess whether assessment of operational requirement and the risk is done. And similarly, we whether check whether there are solutions of those things or not. Now, the last part that comes in is the scheduling feasibility, that is SL. Here, the assessment of the timeline and the scheduling is done. Like what is the timeline, whether we can complete it before or not, how much time it's going to take, or what we do, what should we keep as a deadline, and such more things are done. And similarly, as we discussed, the requirement analysis is always present. The aim of this phase is obviously to understand the requirements of the customer, document it properly, and if we go in a bit more detail, it actually contains the two parts. It contains gathering and analysis, sorry. And the second part comes in is the specifications. Once the data gathering is generally done through the customers or the users, can interact with our current new system or management and such more. We try to ask as much as open-ended or closed-ended questions, so we can gather as much as variable data that we can, that could be required in our the further in the software. Then we conduct surveys, group interviews, we observe feedbacks in the form of feedbacks, and then we analyze whether the SRS or other documents that are currently present for the same thing. So this being the first part, as now it becomes a bit more clarified why this model is called the waterfall model. As we can see, this goes only one way. No matter what phase we are in, we can't ever go back to the previous phase. And the only moment of the coding lifecycle that we can discuss is this way. That's from top to bottom, in other words. Now this now, as we have seen, like it's very tough to actually go back to the previous cycle and check whether what defects we have. If there will always be defects. That's why it was a bit more modified and transformed into the iterative model, right? So what happens in iterative model is we move into the next phase, but from the next phase we send the feedback to the first phase. So basically what happens is there are any defects or there are any detection error or such things, we send back the data like, okay, this is the defects that we have found before proceeding to the designing part. So for example, let me start. Okay, so let's start with the designing, right? So we have got a basic idea like what we need to design. The SRS is ready, and then we have moved to the implementation part, right? In implementation, we found that the SRS is not complete. It is missing some functionalities, or the functionalities are written in a more ambiguous or the vague manner, which could cause a problem. So in the implementation phase, from the implementation phase, we'll send back the SRS to the designing phase and we'll tell them to rectify this error, so that before we are actually implementing the requirements from the customers based on analysis of the data gathering, we potentially try to resolve the errors or the defects or the issue that could actually come in the later part of the life cycle. So it is basically done to reduce the redo cost. As we have seen, it moves only in one way, the waterfall model. So if we get that errors in a verification, unit testing, or the maintenance part, it is a bit tough to actually go to the requirements and then redo the complete work. That's why this model was a bit modified and made in such a way that after implementing requirements, when moving to the design, from moving from one phase to another phase, if there is any error, then it is sent back as a form of error feedback, we can say, so that those defects are actually rectified, and then we again move to the design phase. Similarly, from design, we move to the implementation phase. And if there is any error found, we again send it back to the designing phase. And this is how the iterative model works. Hope you're keeping the notes. Okay, moving on. So since we have learned like iterative model or the classical waterfall model, there must a question: why use it, or when can we use it? So there are actually a specific set of rules when we can actually use it, since we know from the classic or iterative model that the requirement analysis or the feasibility study is the most important one, right? So we can only implement waterfall model when we know that the requirements are constant and are not changed regularly. It's fine if it's getting changed at a long term, like after 4 years, 5 years, or such. Means the changes are not regularly done. They take actually a gradual amount, good amount of time, and the project is short. It should not be like the project is very complex or it's very big. In that case, it actually becomes a bit of more hassle work, because each time you have to implement something, you have to start the waterfall model or the cycle from the start to the end, and the situation is calm. That basically means you have a time, you have the time, you can deliver your project, and the model being you have thoroughly examined each and every phase. Everything is going in a very calm method. The fourth point comes in, like the fourth situation when they can be used, or the rule is the technology and the tools are consistent and is not changing. For example, if you have picked a framework or a mix of a frameworks, it should be that those frameworks are able to actually is able to add more features if it's being used or being maintained after a long period of time. And since it is, as I said, it moves only in a linear forward manner. Therefore, the resources should be well prepared and be available to use, so that if anyone is looking for any way to make the changes, they actually know where to make, what to make, and such. But that's about its implementation. There are much more implementations depending upon the model to model, software to software. But it's still the waterfall model. It's still one of the most widely used model, well, as in the SDLC, and even after coming up with the agile and much more uh, developer suited or the customer suited to be precise, it's still being one of the places, the project that is being used uh, by far. Okay, then moving on to why and why not to use the waterfall model. Like as we have discussed, each and every software is different. Some are short, some are long, some have a constant requirements, or some the requirements get constantly changed, and much more. So depending upon it, we get actual idea when we can use it, how we can use it, why should we use it. So the why part of the question is answered. So it is basically a simple to implement, right? Because it was the first, as I might have talked about it quite a time, as it is the first, and I might have said that too frequently. Since it was a first, it was easy to implement, so that everyone can understand it and execute it. And therefore, the requirements are also simple, and they are explicitly declared, like what are the requirements, what we need. It's very fixed. And since the feasibility study is done at the first stage, even before the requirement analysis, the start and the end point of each phase is thoroughly decided and fixed. So therefore, it gives a easy control and clarity to the customer, right? They also know when, at what point of time, our project will be at what phase. And therefore, the since its release date and its final cost is predetermined before the development, it becomes actually a very easy to allocate the resources and just move ahead. Even if we can actually, since we have a more time, or these are generally pre-launched, so we have a few time for more thorough testing and maintenance part. But there is a disadvantage of cost to these things. The risk factor is very high, and this model cannot accept changes in requirement, as we have discussed. Like if there is any changes, we have to go through and redo the complete work since the beginning to the end. Therefore, it's not a good practice to actually incorporate changes while the software has started into the implementation of the design phase, and therefore it does not allow identifying challenges and risks. Whether it's iterative or classic waterfall model, we can't actually change or detect errors or defects at much frequency or completely. That makes it a bit more constructive, as sometimes there could be a human error, there could be software or the tools and technology error. So we actually don't know what kind of vulnerability there could be or defects could there, and therefore it becomes very tough to actually go back to the previous phase and come to the current one. So that's it for this waterfall SDLC model. Hope you got to learn much more. Hope you got to learn something new. Hopefully seeing into the next video. Thanks.